Hi, so for this session, we will be learning how to find the gradient when given 2 points. So just to recap on what we've covered so far, if we have a linear equation, y equals, just say 2x plus 1, okay, we can identify that this is in the form of y equals mx plus c. Sometimes we have to rearrange this to get it into this form, which we'll be doing in other sessions. But we know the coefficient of x, when it's in this form, where m is here, we know this is a gradient. And then c, we know, is the y-intercept. Okay, and when we have a graph, sometimes we can just look at the points given to us. Okay, the rise and run. So just say here there was 5, and here, this point here was -4. To find the equation of this straight line, well, straight away our y-intercept, where the line crosses the y-axis, there's that point there, it's 5. So we know that c for this equation will be 5. We also know it's a positive gradient going up the hill, not down the hill. So the gradient is positive. So far m is positive. And then all we're going to do is calculate the rise and run between this point and that point. And they're the only points that are shown to us. So for us to get from this point to that point, okay, so we've got, if we rise up here, it's 5 units. So a rise of 5. And then to go across to that point, it's a run of 4. Okay, and there's our gradient. And we don't have to turn this into a mixed fraction, we leave it like this. So according to this graph, the equation of this graph is going to be y equals, we have 5 over 4, and you can write x like that. S can also sit on top, it's up to you how you want to write it. But if it's in the middle, it's really on top. And the y-intercept was positive 5. So just as a quick recap, we have found the linear equation of this straight line with the information given to us. And we can do this, calculate the rise and run this way by looking at the graph. Because 5 units up and 4 units across to get from this point to that point. And of course, it's a positive gradient. Now, what if we don't have a graph and we have to calculate the gradient? What if we're given 2 points? And if you notice, if you look at the graph, to calculate the rise and run, it's simply the difference between the points. So to find this length here, we'll just go 5. This point here of y, we know x is 0 and y is 5. That's the point. And this point here, x is -4 and y is 0. And so to find this length of 5 units, all we're going to do is go 5 take away 0, and it leaves us with this line here, the rise. And to find the length of this line, how many units, we just go 4 take away the 0. Okay, so this one's pretty easy. But then sometimes we don't have a graph given to us. And so knowing that to calculate the rise and run, all we're going to do is find the difference and subtract. We can use that idea to calculate it. So a question will look like this. Find the equation of a line passing through these 2 points. So of course, to do this, the points have to be part of this line. Now we can't see the graph, so we can't just do our rise and run, but we can simply calculate the difference. And the formula you have to remember is the gradient m is equal to y2 minus y1 over x2 minus x1. That's a 1. And that's it. So label these points here. The first point can be your first point, or it can be a second. It doesn't matter which one you start off with. It'll give you the same thing. But always label so you don't make a mistake. So this is our first point, and that's our second point. So our first point, x here, is x1 for our first point. And that means y here is y1, because it's our first point. Here, we know that's x and y, but this can be x2 and this can be y2 for our second point. And now all we have to do is substitute these values into the formula. But please be careful of negatives as well, okay? Because remember, 2 negatives may make a positive. So we have m equals, and the way I do this, just so I don't forget that there's a negative here and here already, I put them there straight away, okay? And then I'll substitute the values in now. So y2, what's y2? Where's y2? y2 is positive 4, so 4 goes there. y1, remember this negative has been taken care of already. So y1 is, where's y1? Here it is, it's -1. So we put -1. And then x2 is -3. So we put -3. And x1, here it is +2. And you can see why it's so important to be careful with negatives, because here, two negatives sitting together make a positive. These two negatives are not together, so it's just -3, -2. Okay, so we end up with, I'll squeeze it in here, what is 4 plus 1? That gives us 5 over -3 -2 is simply -5. And then, so that's m equals +5 divided by -5. So m will equal, well, -1. And there is our gradient. We have found the first part of our equation. It's a negative gradient and it's 1, which isn't too large. So we have found m, and before on the other page, m equal -1. So at this stage, instead of having m in this equation, we can substitute -1. So we got y equals -1 x plus c. Now we know that -1, the 1 can be invisible, so we can have y equals -x plus c. Now we haven't finished solving our equation yet. Finding the linear equation that passes through those 2 points, because you notice we haven't found the y-intercept c. And we can't just look at the graph because there is no graph given to us to locate that y-intercept. Now this part students tend to find the hardest, but all you have to do is substitute one of the points back into this equation here, okay? And so you put in a y value and an x value. But we won't do it for this one. We'll do another example and then we'll continue. So once again, the same question. A line is passing through these 2 points. Find the linear equation of that straight line, okay? And just to recap, we know every line, any straight line we see, has its own equation, okay? And it can always be found if you have enough information, of course. Okay, so once again, using our formula, we got m equals y2 minus y1 over x2 minus x1. Okay, label our points. So we got, this can be our first point. So we got x, well, we've got xy, xy. We know x comes first in our points. Because it's our first point, that's x1, that's y1, that's x2, that's y2. Sub them in here and be careful of any negatives. I notice they're all positive, so it's okay. So negative ready. Y2 is 6, and then minus y1, which is 4. X2 minus x1, 3 minus 1. And we end up with m equals 6 minus 4 is 2 over 3 minus 1 is 2. So this equals a positive gradient, a +1. So similar to the other equation we had, the other gradient. Okay, so now let's substitute m equals 1 into the equation. So we know the linear equation is in the form of y equals mx plus c. And we found m. M is +1. So far we have this. Y equals, you can write 1x if you want to see it more clearly, but we know that 1 can be invisible. Now let's find c, okay? So this is the hardest part, I guess. Now to find c, like I said before, substitute one of these points into the equation we have so far. You can use any points. This is x, this is y, this is x, this is y. Any one you use, you will get the same answer. So maybe let's pick the first one because 1 is a smaller value and it might make our working out a bit easier. So we're going to substitute. So to make it more clearly, when x is 1 and y is 4, let's put it into the equation we have so far. So I'll write the equation down here again. So we've got y equals 1x, 1 can be invisible, plus c. So when we substitute these values, we will be solving for c, trying to find what c is. So instead of y, I'm going to put 4, and instead of x, I'm going to put 1. So we have 4 equals 1 plus c, and now we can just solve this linear equation. It's a +1. If you want to have C on this side to work with, we've got 1 plus C, so 1 plus C equals 4. If that helps you, just rearrange it that way. You haven't changed anything, you've just put the equals 4 on this side. So that's a positive 1, so we minus 1, minus 1. So C is equal to positive 3, and that's our y-intercept. So now let's finish off our equation. So far we had y equals, the gradient was 1, x, and now look, C is, the y-intercept is positive 3. So we just write, I'll change the colour, I'll just write plus 3. And that's it. We have found the linear equation of a line passing through those 2 points we started off with. We didn't have the graph to do this. We just used our knowledge on that the difference of those 2 points will give us the length of the rise and run. Okay, and like I said, this one can now be invisible, so the final answer would be y equals x plus 3. And to have a quick idea, it's a positive gradient, so it's going up the hill. The y-intercept is positive 3, so I can say here it is, positive 3, and that is a rough sketch of what our line will look like. It's not a very steep gradient. We haven't found the x-intercept. We'll be learning that later on. Now the next question, it looks a little bit different because we are given different information, and let's read it. It's asking us to find the equation given the following information. The gradient, because we know m means gradient, is 3, and we're given a point where x is negative 2 and y is 7. With this information, we can actually find the equation of this straight line. And if you don't realize, they've given us the gradient. We don't have to do this. y2 minus y1 over x2 minus x1. They've done that for us. So far we have y equals, instead of mx, we have 3x, okay? But we still have to find what? We still have to find C, okay? So a lot of the work has been done for us. Now we've got to find C, and that is why they've given us this point. They have given us this point because we need this point to substitute when x is negative 2 and y is 7 to find the C value. So let's do that. So when x is negative 2 and y is positive 7, we'll sub it in. So we're going to have 7 here, and we're going to have negative 2. Sorry, we're going to have 3 times negative 2 here. But let's just sub it in properly. I'll just clear that so it's not so messy. Here we go. All right, so when y is 7, we got 7 equals, now in between the 3 and the x, there's a times. So 3 times, and what is x according to this point? X is negative 2 and plus c. So now we've gotten rid of the x and y variables. We have one variable c. We can solve this now. What is 3? So we can do this bit first. What is 3 times negative 2? Well, that's negative 6 plus c. Okay, and I'll just make some more room at the top. So if you don't like having c on this side, I'll just write it like this. We've got minus 6 plus c. There it is. Minus 6 plus c equals 7. So equals 7. And now all we have to do is solve for c. So we've got negative 6, so we plus 6 on this side, and plus 6. So c will equal 13. And we have found the y-intercept. So the equation of a straight line, okay, so our final statement, I'll rub up some more down here. So hopefully on your paper this is in order because you've got more room. So your final statement should be, we haven't done this in the other questions, therefore the equation, just so what you found is clear, is y equals, the gradient was 3x, so it was 3, they gave it to us, and a positive 13 for our y-intercept, plus 13. And that's it, we're done. So just always read and check and see what information is given to you. And sometimes they've done a step for you, and sometimes you have to continue. So for our last question for this session, if you have a look, it says find the equation with an x-intercept of negative 2 and a gradient of 6. So first important point, they've given us the gradient, m equals 6. So that's done for us. So far we have y equals, instead of mx, we have 6x, but we have plus c. So we need to find c again. But is there a point given to us? I don't see a point like this. Just say negative 2 and 6. Do you see a point anywhere? No. but you have to be careful and read it. Find the equation with an x-intercept of -2. That is a point. And we know the x-intercept, y has to be 0. So we have -2 and y is 0. And there is a point in this bit of information. It may not be obvious, but using our knowledge, okay, if we have an x-intercept, okay, y has to be 0, and the y-intercept, x has to be 0, okay? So that's the point given to us. And now we substitute this point into our values. So we got y is 0, so 0 equals 6 times x is -2 plus c, and we've got 0 equals 6 times -2 is -12 plus c. And when we solve it, so plus 12, c will equal +12. And there we have it. So the equation of our straight line will be y equals, gradient was 6, so 6x, and we just found c. C was +12. And there's our equation of our straight line. So just remember, if they've told you the x-intercept is -2 or the y-intercept is 1, you have to remember, an x-intercept, y has to be 0. The y-intercept, x has to be 0. And therefore, there's a point given to you. So don't forget that. Thank you.